Hello, everyone. Nick Stanford here to continue demonstrating the power of the new Marlowe TS SDK. In this video, we'll begin to increase the complexity of our smart contract, introducing a more real use case and handling choices from our user. This video builds on past videos in the series, so if you haven't seen them yet, be sure to pause this one and go check them out. In this demo, we're going to build a smart gift card. If you've ever given a gift card just to see the funds wasted at the bottom of a purse or a wallet, only to expire and be gone forever, the smart gift card is the solution to that problem. It will allow us to specify an amount, a receiving address, and a deadline. If the gift card receiver doesn't spend the amount before the deadline, the money is sent to charity instead of being wasted forever. So the steps of our contract are as follows. First, we need to deploy our contract, make a deposit from the buyer, get a choice from the receiver, send the funds to the right address, and then close out our contract. So let's jump over to the playground and see what this looks like. So I'm inside the playground, and I've got my contract here as blocks. And we can see that as we begin to talk about more complex contracts, they're going to become a little bit more difficult to read. So one of the things you can do is sort of right-click here and then collapse the blocks to just keep track of each section of the blocks as they begin to grow. So I'm not going to get too much into actually designing this contract. We'll do that in another video. But one of the things I do want to show you, we'll jump over to the simulator and see that I've got the amount formatted here to convert ADA to Loveless already. So you need to go to Edit Source, and down here in the bottom left, you'll see Metadata. And then you can scroll down here to Value Parameter Descriptions. And really all I've done is change this from the default format to a fixed point amount, specified 6 zeros for that 1 million conversion, and then typed ADA so that it knows that's the currency that we're talking about. So we'll go back to the simulator. We need to make sure that our timeouts are accurate here, and then we can begin to execute our contract. So the timeouts look good. Let's click Start Simulation. And the first action that we have is to get this deposit of 5 from the buyer and send it over to the receiver's account. So we'll execute that. And then we get the choice action here. And now this is on the receiver side, where the receiver is deciding, do I want to make a purchase or not? If the purchase is made, the funds will go over to the shop. If not, they'll go over to charity. So we'll select 1 to make a purchase, execute that, and then we can see the transaction log here, where we got the deposit, we made that choice of 1, and then we paid out from the account of the receiver into the shop's account. Okay, and then the contract is just going to close out. But let's explore the other option here as well. So we'll reset. And in this case, let's donate the funds to charity. We'll click Start Simulation. We'll get the deposit from the buyer, but this time our choice, we're going to leave as 0. So we'll execute that. And now we see that the contract pays 5 from the receiver to charity instead. So those are the execution paths. We could also test the timeouts here. If you wanted to force the timeouts forward, you could make sure that those execute correctly. But let's jump over to VS Code and take a look at actually building and working with this contract. So as a reminder, if you want to take this over to VS Code, you just want to click Download as JSON here, and the file will pop up, and then you can import that over into your VS Code. So we'll jump over to VS Code, and we see I've got my smart gift contract TypeScript file here. And already I've imported all of that JSON and then formatted it to look nice and pretty. But again, as we start to talk about more complex contracts, you see that it becomes a little bit more difficult to read, especially when it's formatted as JSON here. You have to sort of read it bottom up. So what I'll do is on this when here, we can just collapse that and see, okay, here's the deposit timeout that correlates to that first action. We can open it back up and see, okay, what's the next action? So then here's the initial deposit, right? And the deposit timeout is right below that. So use this collapsing method to sort of break down the contract and understand it, and understand that we need to read this in a bottom-up way. So after we have our initial deposit, what's the next thing that happens? So we'll collapse then, and the next thing is that choice, right? So we see here the choice setup. So it's important that you understand the flow of the contract and how to read this JSON. I like to call it and say bottom up. You need to understand the JSON. So we've got everything here parameterized, and I've covered this in previous videos, but basically the point is to put in parameters here instead of hard-coded values so that you can get inputs from the UI and then pass them in and create a contract from that. So now that we've got our contract, we've exported this make function. let's jump over to our React application and actually start the build. So here we are inside of our app file. And inside of our app file, the first thing we want to do when a user decides to buy a gift card is actually prepare our smart contract and deploy it to the blockchain. So here are the steps that we need to complete from the buyer's perspective. So we need to prepare addresses, connect to a runtime instance, build the smart contract, and then submit and wait confirmation, and then also get a deposit from the user. 6 and 7 here are for the receiver, so we'll get into that in a different function. But let's open up this handle by gift function, and this is just triggered at the UI. So the user will input an amount for the gift card and then also an address to send that to, okay? The first set call here is just going to turn off that button at the UI. And then we're going to do what I've called prepare addresses. So all of this is should be familiar from previous demos where we have this wallet choice. We've allowed the user to select some wallet at the UI, and then we're formatting that as a supported wallet and then retrieving the address from that wallet. Again, this won't be necessary in the future. Again, the TypeScript SDK is in beta, so a lot of these things are changing. And one of the things that is changing is that we're actually going to wrap this inside of get change address. So you won't have to make this call in the future, but just keep an eye out on the releases for the TS SDK to know when that comes. So continuing on our address preparation, we've got our two parties here. We've got the buyer and the receiver, and we've specified them as parties denoted by the TypeScript SDK. And then we're connecting to a runtime instance. So we're passing in that supported wallet and we're passing in a runtime URL. These are all things that we've demonstrated several times in the past. So if you need more in-depth explanation, go back and watch the video on those. But for this video, we're going to start right here. So the buyer is already connected. We've already got our addresses and everything prepared. What do we need to do now? So let's scroll back up. Build smart contract is where we want to start. So I know that I've got the amount that we want from the UI, and now we just need to format that to loveless. So we can say const amount loveless equals parse ADA, and then pass in the amount reference. Parse ADA is a function that I've defined inside of this repository. I can scroll up and show you what that looks like quickly, but really it's just making that conversion from ADA down to loveless so we can send that into the blockchain. So we'll go back down. Now we've got it in loveless. So what we need to do is actually call our make smart gift function. We'll say const s gift contract equals make smart gift. Pass it in. We see the pop-up here. We need the amount, the buyer, and the receiver. So we'll pass it in amount loveless, buyer, receiver. Okay, so that'll actually send back a contract type with all of our parameters set inside there. So the next thing we need to do is actually submit that to the blockchain. We can say console.log, submitting contract to the blockchain. Okay, now to actually submit this, it's going to return two pieces of information. It'll return the contract ID and also the transaction ID. So we'll await that, and that comes from the runtime lifecycle object .contracts.create contract. Again, this is something we've done in the past. And now we just need to pass in the contract. This is sgift contract. Okay. Next on our list is to actually wait for confirmation of that transaction. So we can say contract confirm. We'll wait our browser wallet .wait confirmation for that transaction ID. Now the JavaScript should sit and wait for the transaction to confirm before it moves forward. So we've built our smart contract, submitted it, and waited for confirmation. Now we need to prepare and submit the deposit. Okay, how do we do that? This has also been done in previous demos. I believe that one was called Simple Demo, if you want to check that out. But we'll walk through all of that as well. I know I have my amount loveless, right? But we need that as a big int. So I'll say big int amount. We'll pass it into the big int constructor, and that is just the amount of loveless. So now we have it as a big int, and we need to formulate our deposit. We'll say const deposit is an I deposit. And I know that TypeScript expects input from party. For us, that's the buyer. That deposits a big amount of what token? We know that's Loveless. And then into what account? The receiver's account. Okay, so there's our iDeposit. And now we need to formulate that as an input. So let's do that. We'll say const deposit inputs. Make sure I spell it right. Is an input type, and it's equal to that deposit we just defined. You scroll up here so we can get a little bit better view. Now we've got it set up as an input, and now we need to set it up as an apply inputs request. So we'll say const deposit request is an apply inputs request and pass it in those inputs. Okay, this setup is going to be familiar from previous demos, but we're also going to use the similar setup for applying choices here in the future. So just be aware of that. Now we can say console.log applying deposit transaction, and then say const deposit transaction ID equals await the runtime lifecycle object dot contracts dot apply inputs. Pass it in the contract ID and then our deposit request. So this will be the same when we go to do choices, just how we formulate the inputs is going to change. So we'll say we have our deposit request submitted. Now we need to wait for it to confirm. We'll say const deposit confirm equals await the browser wallet dot wait confirmation for deposit transaction ID. So now the JavaScript will sit and wait for that to finalize. Let's add one final console log here to say console.log deposit confirm is, give it that Boolean value. And then we'll say the contract is waiting for a choice from the receiver. So just to verify, let's go back up to the top of our function. See that we've prepared and submit the deposit, waited for the confirmation, and the next is a choice from the receiver. But we need to handle that from the receiver's perspective. So that's handled inside of a different function. We know now that this is the end of buyer interaction. Their interaction with the contract is complete. Everything else is handled programmatically. So now we want to scroll down here to handle choice submit. Handle choice submit is just triggered at the UI by the receiver. They're saying the choice is either to purchase an item or donate their gift card. So we need to do the same wallet stuff as before. We need to connect to the runtime, but the things that are different is that we just need to formulate our choices. Apply inputs and wait confirmation is going to be the same as before. So again, we've got the same wallet sort of maintenance that we're doing here to prepare our addresses. We've got the receiver connecting to a runtime lifecycle. And then let me wipe all this out so we can actually write this from scratch. And now that we're connected to the runtime instance, what do we need to do? We just need to formulate our choices and then apply those inputs, okay? So for the choice name, we know that it's going to be purchase. I can say const choice name is a choice name, and it's equal to the word purchase. If you're curious where that comes from, inside of the Smart Gift contract, you see that I've got the choice labeled as purchase. In future videos, we'll show you how to actually pull this from the blockchain in the event that you don't know what the next action or choice is. But for now, we'll just hard code it. So I've got this purchase, and now I need to formulate a choice ID. So we'll say const the choices that we have is a choice ID, and it's equal to what? Oh, make sure I do that correctly. And what it needs is a choice name, which we've just said is that purchase, and then a choice owner. And we know that the receiver owns this choice. Okay. So now that we've got the ID set up, we need to set up which choice the user is going to make. What is my choice? So we'll say const The purchase choice is an I choice, and that expects for what choice ID, we've just specified that as choices, and it also expects input that chooses a number. Now, this is where the user's either deciding to purchase an item or donate their gift card. So that number is coming from this parameter right here. So this is coming from the UI. We're passing it in as a parameter to this function. So I can scroll down, and I know that it wants it as a big int. So I'll just pass it the big int constructor and say choice none. And now we've got the choice ready. So whichever choice the user selected, we're ready to apply that. Now that what we're going to do next should seem very familiar from the deposit, right? We're just going to say the choice inputs is an input type. And now instead of passing in the deposit, we'll pass in the purchase choice. Formulate that as an apply inputs request. Where all we're doing is saying the inputs are those choice inputs. Okay, the next part's going to be a little bit different. We formulated the choice, and now we need to know which contract to apply it to. So what I'm going to do is use our runtime lifecycle object to get back the contract IDs that are relevant to my address. So I can say const the gift ID is await the receiver runtime lifecycle .contracts.get contract IDs. And this will return every contract ID associated with my address. We'll say console.log. We're ready to apply input choice. And now the choice transaction ID is going to come back here when we await the receiver runtime lifecycle .contracts.apply inputs. And this is the same setup as before. It expects a contract ID and an apply inputs request. So the contract ID I just got back as gift ID, and I know that my input request is a choice request. So gift ID here is telling me it doesn't like that because this is an array that contains all of the contracts that are associated with my address. For simplicity, I know that that occurs at position 0, so I'm just going to pass it in position 0. Again, in the future, we'll show you how to get different contracts with different DAP tags and also different parameters to allow you to filter through and find the appropriate contract to apply this to. So now we can say console.log the choice transaction receipt, pass that in, this Boolean value we just got back, and then wait for confirmation of that. Choice confirm equals await that browser wallet dot wait confirmation of our choice transaction. And now all we have to do is output what that Boolean value is. So we know choice confirm is, then just say choice confirm. And that's it. The next comment you see is that's the end, and we just need to check the wallet for funds. So this should run. Let's pull open our terminal, run npm start, and see what this looks like. This should bring up localhost 3000. And inside localhost 3000 will be your React application. I'm just going to bring this over to a browser where I know I have my wallets installed. So here it is. I'll open up my browser console so we can see what's happening. I'll connect my wallet. And right now I'm acting as the buyer. The first thing you want to do is buy a gift card, right? So I'll select my NAMI wallet. It'll ask me, would you like to buy or spend a gift card? So we'll select buy. Maybe it's 15 ADA. Then let's get a to address. We'll go to Lace. We'll grab that receiving address and we'll send it over to ourselves here. Now, the console is telling me we've connected to the runtime instance. We made that ADA conversion to loveless, and now we're submitting the contract to the blockchain. So here's the wallet UI asking for confirmation of that. So we've submitted the contract to the blockchain, and the next step is going to be to apply our deposit of 15 ADA. So we should see that pop out here at the console as well when it's ready for us, and then we can move forward our contract. Okay, applying deposit transaction. Here's the 15 ADA coming out of our account, going into the contract. And now that our deposit's applied, the next thing we should see is that we're waiting for a choice from the receiver. At that time, we'll open up a new browser window and we'll start to act as the receiver in this application. And after that, we should be able to work it through to completion. Okay, deposit confirm is true. The contract is waiting for a choice from the receiver. So we'll open another browser, go to localhost 3000, and now we're prompted here with connecting our wallet again. So we'll connect our wallet, and this time we'll select Lace. I know that's the wallet I used. And instead of buy smart gift card, we'll say spend smart gift card. It says this is a point of sale terminal that accepts your gift card. Please buy a ticket or donate your gift card. Let's select buy a ticket. Tells us it's connecting to the runtime instance and applying our choice. Lace pops up to confirm that transaction. We put in our password. Now here's the transaction receipt from our choice. And now all it's doing is waiting for confirmation of that transaction, and then we can verify. Okay, choice confirm is true. So I know that I've selected this inside my Eternal wallet. I've sent it, the shop address is the Eternal wallet here. So we'll go inside of my address, we'll look at transactions. There we go. Just now, we received 15 ADA for the shop for our gift card. All right, that's everything. We deployed a smart gift card contract. We built deposits, choices, and we ran the contract to completion from both the buyer and receiver perspectives. We're starting to increase the complexity of these demos, so please reach out to us in Discord if you have questions or comments. You can find the TS SDK engineers in the GitHub repository, so please use the discussions and issues section there to reach them directly. Thanks for watching, and we'll see you next time.